this is question 8 from the homework assignment 7-3, but you also saw this on the quiz on Friday. I wanted to see, if we've been taking our factoring seriously, understanding and trying to make sure we're developing that skill. I am going to go back and make that question just a bonus question for everybody on that. But I'm very interested in seeing what we know about factoring, because that's usually where this question causes people issues. Okay, but you will see this again on the test for this chapter, so I think it's very beneficial to talk about and discuss. And I also think it's important to talk about what this question is not and what we're not able to do with this. So, in the event that they would have provided me, let's say they give me that picture, okay, where maybe now there's 39 in x plus 6. Let's say the 39 would have been maybe here, and the x plus 6 is there. If that's all the information they give me, if you were to read the directions, set the two figures below are similar, solve for x. Okay? If they give me the picture set up like this, you don't have enough information to do the problem. Okay? Because we know, or we should know, that this is your longest side, right? And that is your longest side. Why do we know that? Why do we know those are the longest sides in those two triangles? Sarah? Right, they're both across from a 90-degree angle. They're both the hypotenuses right now, right? So if the figure on the right is similar to the figure on the left, then when that figure got shrunk, the longest side is still going to shrink down to still be the longest side in the new triangle. Does that kind of make sense? Now, if I look at the other two sides, that means one of the other sides is the smallest side, right? But am I able to compare and say that 39 is smaller than 2x minus 4? Do we know that? No. Okay. For the same reason, we don't know whether 24 is smaller or bigger than x plus 6. Which means to us then, do I compare? We don't know this. We don't know whether I compare 39 to 24, or do I compare 39 to x plus 6. Does that kind of make sense? So there's ambiguity in regards to what parts compare to what parts. Okay? But because they do provide it this way, okay? They do provide that you have the hypotenuse of 39. Okay? We should know then that 39 should compare to what over here? X plus 6. Okay? The longest side has to compare to the longest side. Okay? Now the argument is, if that's the case, then hopefully it makes sense that because of what we're left with, 2x minus 4 has to compare to what? 24. Okay? That's the only argument we can make. And the reason we can't make any other arguments based on that first picture that I was giving you is because we don't really know anything about the remaining angles up there. We only know one angle congruent to one angle, right? We don't know which acute angles are congruent, which would have then, if we did, would have then allow us to kind of correlate which sides match up. Okay, but that is actually enough information there to allow us to create that proportion. Now it's just a matter of, once we've got that set up, can we go through and cross multiply and get our quadratic equation? Now there's a couple different things you can do, and this is the issue I think a lot of times with the geometry is once we set it up, there's 3-4 different ways that we can approach the algebra to solve this thing. Okay, some people throughout the day have recognized that there is a 2 in both these two terms up here, 2x minus 4, right? And there's a 2 down in this one, Would you guys agree with that? So some people are rewriting this top as 2 times x minus 2 over 2 times 12. Would you guys agree with that? What's 2 divided by 2? It's just 1, right? Okay. So they're actually writing, which is perfectly fine, 39 over x plus 6 equals x minus 2 over 12. If you did that, that's 100% fine. It actually makes the quadratic equation that you're going to create here in a moment a little bit simpler. Okay. But if you didn't recognize this, so I'm going to do kind of the work over here and then jump over here and show you the similar work here. Okay. Over here, you would take those two numbers or those two binomials and multiply them, right? So what's x times 2x? 2x squared. What's x times negative 4? Negative 4x. What's 6 times 2x? 12x. So I had negative 4x and plus 12x. So you can do positive 8x, right? That's the O and I for FOIL. And now last times last would give me negative 24, right? Now 39 times 24 gives me 936. Is that okay with everybody? Now if I'm going to factor, I want to get that 936 to the other side. So I'll subtract it from both sides. I'm left with 2x squared plus 8x minus 960 is equal to 0. Okay? At that stage, I'm going to stop with that. Okay? Because that's in the format now that we could actually start factoring. Let's come over here and draw comparisons. Over here, if I cross multiply, what's x times x? X squared. X times negative 2 is negative 2x. 6 times x is 6x. So those combine to give me a positive 4x. 6 times negative 2 is negative 12. And 39 times 12 gives me 468. Okay. I'm going to remove that 468 from both sides. And I get x squared plus 4x minus 480. It's coming back.
I didn't know how to do these balls.
About every year that happens about twice. I don't know. They've been working with. Could be the. I don't know. I don't want to say yes and then it not be, but something surged. Did that projector come back on? Is that it?
The light screen up there. I don't know.
Is that okay? Is it flashing green up there?
Yeah.
Okay.
Yeah, I was like flashing orange when you said it was green. I was like, wait.
No, I was talking about that up there.
Oh, okay.
So before that happened, we took this 468. That was the product of 3912. We're gonna move that over and get 480, right? What is the comparison? Let's take this blue one. What is the comparison of those two? It's yeah. The top one is half, and the bottom one's double. How do you want to view it? But why? Did I factor this 2 out here earlier? There's a 2 in this one here that we factored out to get this ratio here, correct? So what my argument is, you can factor this, okay? But it makes it a little bit easier if we can factor this one. Now, even if you did write it as this black one, can we do this? Can we go 2, factor the 2 out right now, and write it that way? Does that kind of make sense? And now, that 2 can actually be divided by 2, or this side here can be divided by 2. I can divide this side by 2. What's 0 divided by 2? 0. So I can eventually get that black one here to go down to the same that I had over here. But that the format of the quadratic that I think would be the best for you to factor. And that's, if you go back to your Algebra 1 rules, you learn initially, how do I factor things with a number out here as 1? And if it's not a 1, the first step is to see if everything is divisible by that number. So right now it's a 2. Is everything divisible by it? Yes. So we go through and we divide all things, even the 0, and we get that. Okay. Throughout the day, I keep getting people to say, well, I saw the 2 in there and I just got rid of it. Okay, it just disappeared. Which, okay, yeah, it does, but I need you to understand why, because eventually in Algebra 2, College Algebra, Trig, Calculus, Integrated 3, there's going to be situations when we have like 2x squared plus 8x minus 960, and I factor that 2 out because I need to. But in this case, I can't just let that 2 disappear. Does anybody know why I can't let that 2 disappear? How did this differ from that? This one up here is an equation, right? So I can do whatever I want to both sides. This is no longer an equation. So if I'm going to factor something out, that factor needs to stay. Because when I say x is 0, when I plug x in to be 0 here, I get negative 960, right? When I plug 0 in here, I better get the same negative 960. And if I let the 2 disappear, I only get negative 480. Okay? So when you rewrite an expression, you factor out a GCF out of an expression, it needs to stay. When you factor a GCF out of an equation, you can divide both sides by that GCF, and it can disappear. Or we say disappear, but it actually reduces to 1. Does that make sense? That's a big issue for people beyond this class. All right, I'm going to see that a lot in algebra, and they always wonder, when can I take it out? When can I take it out, and when can I not take it out? Keep doing that. There we go. All right, so now I'm going to factor this thing. So I'm looking for 2 numbers that multiply together, give me negative 480, and add up to give me 0. 480 is a large composite number, right? It's going to have a lot of factors. 2 goes in that thing a lot. So you get a lot of pairs of factors. But what I want you guys to understand is that because this is negative, that's negative, both factors cannot be the same sign. Does that make sense? So positive times a positive would make that number positive. A negative times a negative would make that positive. So one of these numbers has to be positive, and one of them has to be negative. So we should have the kind of the starting point of x plus something times x minus something. If this is the setup of your quadratic equation, there's, I don't want to say a shortcut, but there's a trick for us to find our factors a little bit easier than just kind of arbitrarily choosing things to see if they multiply together to give me 480. Okay? Maybe some of you see, when I look at that, I see 48 instead of 480. I don't know why my brain does it, but I see 48 and I see 24 and 2. Well, if I make that 24 and 2 go to 24 and 20, there I get 480 plus 2 factors, and then they add up to be 4. I don't know why I can't explain why my brain does that, but I see that, and maybe some of you can see that. If you don't see something like that, there are kind of approaches that you can use to help you get to those factors kind of in the same time frame. Okay? If this number is relatively small, okay? Now 4 is pretty small, right? Especially compared to 40 or 480. What you want to do is take the square root of the 480. Okay? And it gives me 21.9. Okay? If I have, so what that tells me, if I take 21.9 times 21.9 and all those decimals, that will multiply together by itself to give me 480. Does that make sense? But if I make one of those positive, make one of them negative, they're going to have to give me 0, correct? So what I want to do is start changing that 21 number by integers, okay? So I'm going to go like 22, okay? Or 23 or 24. And I want to take those numbers and divide 480 by. So taking the square root kind of gives me the starting point, okay? Kind of gives me, I don't want to say middle, but it gives me the location that I want to start trying to figure out where my factors are. because it kind of sucks saying 480 divided by 2, and then 480 divided by 4, and figuring out the factors to go with those, right? If I can start somewhere in the middle of my list of my factors, it's going to allow me to get to those factors a lot quicker. So taking that square root allows me to get in that middle of that list. Does everybody kind of make sense? You remember doing that? Like 1 and 480, 2 and 240, 4 and 120, right? And making that long list. Well, that long list is going to go all the way up, beyond factors of 20, okay, or values of 20. So I don't want to have to write all those out. Don't know what's going on here with all this stuff. So this process is going to get me kind of in the middle there where we're at 20, 21, 22, and then we can use a little bit of division to help us decide which factors we use. So 21 is the number I'm going to start around. It doesn't have to be 21, but I'm going to take 480 and divide by either 21 or 20 or 22, something close to that. Does that make sense? So I'm going to go 22. And I'm going to hit enter. And I'm looking for an output number that is an integer, so no decimal parts. So that's not it. So all I do, and you can go up or down, okay, I'm going to change the 22 by 1, and we'll try to divide by 23. Didn't give me an integer back, so I'm going to increase that number again, go to 24, hit enter, and now I get an output that is an integer, right? So that tells me my two factors. One factor was 24, the other one was 20. 24 times 20 gives me 480. Okay, so now one of these has to be positive, one has to be negative. 24 has to be positive, and the 20 has to be negative. Now some of you might say, well, you're doing, because of those numbers, you're doing maybe more work there than necessary. I can see the 24 and the 20 right away. But that's an approach when maybe that number is something different than 40. I think some people have like 11,044. Or 1,144 was one number some people had. Or 572. Okay? So the numbers aren't maybe as easy to see as 480. But that would be an approach. So now, when I solve this, this is going to give me x to equal what? Negative 24. And this one's going to be x to equal positive 20. The directions say, write your answers with a comma if needed. Well, the question is, do I need a comma? If I use, negative 24, can I plug negative 24 in right here and get a viable distance? No, I get negative 18, right? And distances cannot be negative. So negative 24 does not work. It's an extraneous solution. So 20 is my only solution. It works when I plug it into both parts. So I don't need a comma in my answer. Okay. Does that kind of make sense? Now, if you're a person that says, that factoring blew my mind. I'm never going to be able to get there. My hopes are you don't have that outlook, and that you continue to work and try to get better at factoring. But if you know that you struggle with factoring, okay, maybe in your homework, in the event of trying to get better at it, you try it, you attempt it, okay, or you use this thing. Because that's just plugging in values of A, B, and C, and then evaluating, which hopefully we can all do. And if you do that correctly, you get down to negative 24 and 20. So those would be your answers, obviously removing the negative 24. My thought is, if I've got two approaches and I suck at one of the approaches, I'm going to first start the problem off doing the approach that I'm good at. So let's say I know the quadratic formula. I'm really good at that. I'm going to start the problem with that. I'm going to get my answers. Okay, and I know the answer. I can answer the question. I get my credit for that question. But I know in the back of my mind that at some point I'm going to need to know how to factor. So now I'm going to practice factoring the same exact problem and see if I can mimic those answers, knowing what they already are. Does that make sense? Okay, it's kind of how I would study for things. Knowing the answer before I go through a process, I think, is very beneficial in helping learn a process. Okay, so that's an option. Does that help on that question? Like I said, you're going to see that